Now in this part of the test review for chapter 13, let's do a couple calculations dealing with molarity. I know there's other concentration calculations, mass percent, mass volume percent. Those are less important. I mean, those will still show up on the test. I'm going to let the Mastering Chemistry problems deal with that material. I want to talk about molarity. Molarity is the one, if you use a concentration term later in your chemistry career, most likely it's going to be molarity. So let's spend a little time on it. We have our formula, right? Moles of solute divided by the liters of the solution. So one thing I can notice here, let's see, it's asking for me to calculate the molarity. Okay, so that's fine. I want to calculate this. That means I need the moles of the solute and I need the volume in liters of the solution. Now, the volume in liters is already given, so I can just plug that directly into the formula when the time comes. If I talk about the amount of the solute I have, well, here's the solute and it's given in mass. Okay, so what we need to do now is we need to do a conversion that we first saw in chapter 6, and it's a mass to mole calculation. And then once we have the moles, then we can insert it into the formula and then calculate our molarity. How do we do this? Well, what we did was we divided by the molar mass. Okay, so the molar mass here for the sodium nitrate, you got 3 oxygens, 1 nitrogen, 1 sodium. If you look on the periodic table, sodium weighs 22.99 grams per mole, nitrogen is 14.01 grams per mole, and then oxygen is 16 grams per mole. These two are easy. This one is 48. 3 times 16 is 48. You add these up, and you get 85. Now again, this is grams per mole. So we're going to use this. This is the molar mass. How do we use it? Well, I said we divide by molar mass. Let's take a look at how that works. Just like many calculations we've done, almost pretty much all of them, it's a dimensional analysis argument. Why does it work if we divide by the molar mass? Well, because that places the 1 gram on the bottom, allows us to cancel out the grams. We're left with moles. Not rounding off yet, just over 0.6 moles here. And that's what we want to plug in here. Now let's do that. Again, I'm going to round off at the very end. In respect to sig figs, so look at our original data for the significant figures. Right, there's 3 sig figs there. There's 3 sig figs on that one. So I want to keep 3 sig figs in my final answer. And that's going to be 263 molar. And by the way, when you speak this, 0.263 molarity, that would work, but a lot of times you just hear chemists say molar concentration. Now, this was a problem where it pretty much boiled down to a plug and chug into the molarity formula. I want to do one that's a little bit different. I'm still going to use sodium nitrate, right, because I already figured out the molar mass of the sodium nitrate. And here I want to use molarity formula a little bit differently. What do I have here? What do I need? What do I want to do? Well, I want to calculate number of grams, and this is a new solution. Okay, so I may be using sodium nitrate, but it's a different scenario than the last problem. My volume, 3/4 of a liter. Concentration, 1.23 molar. And if I look at my formula here, if I want grams, well, grams is nowhere to be found. Again, what I have to realize, right, moles and grams are related to each other. You know, in the last problem, we went grams per mole divided by molar mass. In this problem, moles to grams, we're going to multiply by the molar mass. Well, the first thing I'm going to do is actually calculate moles. How do I do that? Well, just like a lot of ways, there's a couple ways to approach this problem. Okay, one is that you can actually use what I call the equation triangle, and I imagine a lot of other people do this. So if you have an expression where it's something is equal to two things divided by each other, molarity equals moles divided by liters. So anytime you're crossing over the horizontal line, that's a division operation, and then if you're crossing over the vertical line here, it's multiplication operation. So how does this work? Well, if I want to calculate moles, right, I need to calculate moles first before I can get to grams. Right? That's my ultimate goal here. So I want to calculate moles. And then what is this saying? It's saying molarity times liters. There's my new formula. Basically, the equation triangle is allowing you to have training wheels when doing algebra. Totally fine. So there's my math. And then once I get moles, we'll worry about this next step. So basically, this is going to be our first step, and this is going to be our second step. Why is this our first step? Well, look at the data we have. We have concentration, we have volume. We start with the data that's given. So if I want to calculate moles, I said it was a concentration. I'm going to leave the units blank just for a second, and then the volume. So the reason I'm doing this way is because I want it to look like a dimensional analysis problem. Basically, any problem can boil down to a dimensional analysis problem at some level. What is embedded within that capital M? Well, capital M is defined as moles per liter. Look what happens when I multiply concentration and liters together. Well, units cancel out. The unit that I want is moles, and that's what we're going to get. I think I'm going to pause and not do the rounding off yet. So I almost have 1 mole of the sodium nitrate in this particular solution. And now I can do my final calculation. Let's squeeze it in down here. So I take the number of moles. I want to multiply my molar mass. And I said, right, we already know that. And again, why does it work here? Why does multiplication work? It's because if you multiply by the molar mass, moles cancel out and you're left with mass. Let me just go ahead and factor in the sig figs. We have 3 sig figs there. We have 3 sig figs there. Therefore, the final answer is going to have 3 sig figs. And that comes out at 78.4 grams. That'll do it for molarity calculation. In the next video, it'll be short. We'll be dealing with solution dilution.